Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we're going to be doing lesson number 15, and the good news is lesson 15 is the end of the course for us. So alhamdulillah, we started off in school in the month of September, and we started off from chapter 1, the tools of geometry, and about 7 to 8 months later, we have completed the course, and we are at lesson 15. Okay, so alhamdulillah is all we can say. Alright, so let's get started. Today's lesson is quite a light lesson. It has been split up into two parts just to make things a little bit more manageable for you guys. So we're going to be just kind of working with inequalities and graphing inequalities and solving inequalities. So in number 12, it says, can you can you take the graph that's been shown and express that in interval notation and then express it as an inequality. Okay, so we're going to be doing those couple of things here. So let's start with the graph number in number 12. So what you're looking at in number 12, this is called the graphical notation, or just simply the graph. But another graph that you've often seen of the same exact situation, and through middle school you've seen this graph, is you've generally seen a -1, a +2. I'm just picking the relevant numbers, and instead of this really old school notation, these are actually parentheses on top of the -1 and 2. The notation that you guys have generally seen is open circles. So what I'm trying to say here is the open circle and the parenthesis, they correspond to one another, right? Now you might be thinking to yourself, what about a shaded circle? So we'll do that in just a moment, right? Now the other notations that you can write this in, the first one is called the interval notation. Okay, so the interval notation, and the interval notation for that same exact fact that I just showed you, it looks like the following. It looks like parenthesis -1 and then 2 parenthesis. So it's not -1 comma 2 like x comma y. Okay, that's actually a way to represent the same answer that you're looking at over here, right? So that's one of the reasons why it makes sense that the highlighted parts are in parentheses, because it really connects from that notation to the interval notation, whereas open circles, it's like, wait, what does that open circle mean? But I know that I have seen the open circle notation on the ACT, so please don't forget about that one. Okay, it's still relevant for you. And the last notation is the inequality notation, and the inequality notation looks like the following. You write down -1 less than x is less than 2, like that. Okay, and a good way to read it is x, all right, x is between -1 and 2. All right, that's an easy way to read it as well. All right, let's try another question. Let's take a look at number 14 here. Number 14, it gives you, once again, a graph, except the difference is now the left end is continuing to be shaded, right? So think to yourself, what did that used to mean? Well, the interval notation for it, all right, the interval notation for it is going to look like the following. You're going to have parenthesis -∞, comma, 0, bracket. And the bracket means that that number is actually included, whereas parentheses, recall in an open circle, it meant that -1 and 2 were not included. So -1 is not included, and +2 is also not included. So in this situation, 0 is included, right? But the -∞, just think about the idea of -∞. You can't ever reach -∞, right? If you don't understand, what do you mean by -∞? So look, there's -1, -2, -3, and so on and so forth. So you continue to go in the negative direction to infinity. So we call that -∞. All right. So this is the interval notation. I know it's kind of weird and it's odd for a lot of students, but here is the inequality notation, which for many students is like, yeah, I would have written that anyway. The first way to write it is -∞, x less than 2, All right, that's one of the ways to do it. And now watch what I'm going to do just to kind of drive the point home. On that right side, I'm going to shade, sorry, not shade, I'm going to put a little equal sign underneath the less than. And what that means is the 0 is included. I apologize. I shouldn't have written 2. I meant I got crossed up between the one above. And so 0 is included. All right, like that. Then if you were to have something that was going towards positive infinity, you'll see that eventually, I think, when you do your homework, possibly. Let's take a look at number 16. All right. Number 16, the first notation that we're going to use is the interval notation. So the interval notation for number 16 is going to look like the following. You're going to have, bismillah, negative 1, right? Negative 1, comma, positive 1, and there's a bracket on that side. So this is called the interval notation. The inequality notation, all right, so inequality notation, it's going to look like negative 1 is less than x is less than or equal to 1. Again, you want to kind of just make that connection there. Let me make a different highlighter, but you want to make that connection that the less than is the left parenthesis, the less than or equal to is that parenthesis right there. You don't make it like greater than or equal to or anything like that, okay? Which reminds me, just one little point to make. For this notation right here, there is a secondary way to do it, and that secondary way to say it is to simply say x is less than or equal to 0. This is also acceptable. Both of these are acceptable answers. All right. Now, let's continue, inshallah, and we're going to go to the next standard for this lesson. And the next standard is not a whole lot different than the first standard, but these are all very important things that you need to know in calculus, right? So in this one, it says now we're giving you the inequality notation, and your job is to illustrate this, illustrate each inequality, meaning make the graphical notation. All right, so illustrate meaning make the graph, and also use the interval notation. So the interval notation. So recall what was the interval notation that we talked about above, and we're going to be doing that. All right, so we'll just take one of these. We don't need to do all of them. So I'll take, bismillah, number 30 right here. Okay, number 30. Number 30, if you want to go ahead and write it as its interval notation, right? So recall what was interval notation. It's the one with the parentheses and the brackets. So basically what you have is you're saying x has to be a number that's greater than 1. If you want to do them in a reverse order, it might make a little bit more sense for you. So if you want to graph it first, that's fine. So here's the graphical notation of number 30. You basically are going to make a number line. All right. So here's my number line. And then it says x is greater than 1, so I'll just make a number 0, and then I'll make the number 1. All right. Even the 0 is not that necessary. So when they say x is greater than 1, notice how it doesn't say equal to 1. So here's graphical notation. I'm going to make a parenthesis, and then I'm going to shade to the right of the parenthesis, like that, including the arrow. How is the other way that you guys have been doing it in middle school and you still need to know? Well, basically the same exact idea. So this is still a graphical notation, but this is the second kind of graphical notation, is you can make an open circle at 1, and then you can shade to the right of 1 like this over here. That's also acceptable. Both of these are acceptable answers, all right? And I do need you to know both of them, please. All right, now we're going to do the same thing, but for interval notation, all right? So interval notation for that same exact idea. In interval notation, basically all you got to do is just write down 1, because that's basically this notation, right, written as an interval. So it's 1 with the parenthesis on its end, and then positive infinity, or you can just write infinity, and that also is a parenthesis. Remember, whenever you have infinity, it's always going to have a parenthesis on its end because you can never get to infinity. You can never include infinity in your conversation. Okay, let's do one more from the bottom set now. And of course, I think you guys understand that this time you've been given the interval notation, and your job is to illustrate this using an inequality as well as write the inequality. Okay, so we can honestly take anything here that you guys like. So we can take number 36. Actually, no, even 36 is kind of useless. Let's do 34. Not useless, sorry. I'm just saying we kind of just did this a moment ago. So we have 0, 1. And please realize this is already the interval notation. So we want to write this as an inequality notation. And if you wish, you can graph it first. Okay, you can do the graphical notation first. No one's asking you to do it in the same order. So you got 0, you have 1, and then you're going to put a bracket on the side of the 0, and you're going to put a parenthesis on the side of the 1, and you're going to shade between them. So that's one representation, but you'll notice that this is so odd the way it looks, right? So I personally prefer the middle school way, even though it's kind of babyish, but 0, 1, and I'm going to shade the 0, I'm going to leave the 1 open, and I'm going to shade between them. Okay, so these are both the graphical notations. Alright, they're both acceptable, and you need to know both of them. Now the inequality notation for this is only one. You put an x in the middle, you put a less than or equal to on the left side, and put a 0. You put a less than on the right side, and put a 1. Please realize that the left bracket is what caused that equal sign to occur, and the right bracket is what caused the equal sign to not occur. Sorry, the right parenthesis. So just so we're clear, whenever you see a parenthesis, all right, whenever you see the parentheses, that simply means that it's going to look like that. If you see the bracket, right, the hard bracket like that, then it's going to look like less than or equal to. So these are simply notations that you need to know. All right, now the next objective that we're going to do is to kind of really go over one rule that I feel like we talk about a lot in middle school, but then if you forget it in high school, you kind of have a problem with it later. So let's take a few of these questions here and just kind of go through them. So number 42, right? Number 42 is a very simple one. It says if x is greater than 6, right? X minus 6 must be what? And the answer to that is x minus 6 must be greater than 6, right? Here's how I've always told students to do it. I tell them, what if you had the question, right, for number 42, what if you had the question, x minus 6 is greater than 0? If you had to solve it, what would you get? You would get x is greater than 6. So they're just working backwards for you there. I know it's a really weird way of asking the question, and I sort of get why they do it, but oh well. Number 46. This one's very important. Let me write it down. Number 46 says that negative 4x, right, and they're giving you a blank, and they're giving you a blank and saying 8, and it says that the answer should be x is greater than negative 2. See how I wrote that, right? I just went backwards with it. I just wrote down negative 4x blank 8, and then x has to be greater than negative 2. So let's think about this really quickly. What did you guys learn in middle school to solve something like this? Any inequality it had, you would have remembered that you need to divide by negative 4 on both sides. But recall, when you divide by negative 4 on both sides, what it does is wherever the inequality was, right, divide, this is a golden rule of inequalities. Whenever you have an inequality, if you multiply or divide by a negative, it causes the sign to switch. So initially, it must have been looking like this, right? And then negative 4's cancel out, so you're left over with the x, and that's why it switched up and it looks like the following. So what I mean to say here is this must have been negative 4x is less than 8 is what they're really trying to go at. All right. Now let's try one more. Let's try number 52. Number 52, again, I'm just going to write this the other way. I'm going to write down x blank negative 4. and they're saying, what can you say about negative 1/4 x is greater than 1, right? It's, again, a very different way of asking the question, but inshallah khair. So now I want you to think to yourself, how can you possibly get this negative 4 to look like that, right? What they must have done is they must have divided by negative 4 on both sides, right? They must have divided by negative 4 on both sides. And because, once again, because of the same thing that I said to you in number 46, because they're dividing by a negative on both sides, that means the inequality, wherever it was, it must have switched up and it looks like that right now, right? So in other words, this must have been looking like the following before, and then after you actually did the division, you end up with negative 1/4 x is going to be greater than positive 1. All right? So remember the rule that whenever you divide or multiply by a negative, you're going to end up with the sign switching. Now here is something, I just want to mention this to you because these questions have been kind of odd. Here is something that students often get mixed up by. What if I tell you that 2x is greater than negative 6, right? And then you divide by 2 on both sides, right? You divide by 2 on both sides, the 2's cancel out, and you're left over with x and negative 3, right? What do you do now? Is it going to look like this, or is it going to look like that? Is it greater than or less than, right? And the answer to that question is the answer is still greater than. And a lot of students get confused by that. They're like, wait, I thought if you divide by or multiply by a negative, this is what happens. And that's precisely what I had said. I said if you multiply or divide by a negative, that 2 was not negative. And because that 2 is not negative, you're not going to flip the sign on the inequality. So a lot of students, they make that mistake. And I wanted to clarify that for you, that only when the number that you're using to divide with is going to be negative, then and only then does it switch up inequalities. All right? And one last little comment. If you don't understand why that rule is, a lot of students don't, right? So here's a quick example for you. 7 and 9, which one's greater? All right? 9 is greater than 7, or 7 is less than 9, however you want to look at it, right? Now, you always read these from the left, because there's some people in your class who read them the wrong way, and I guess they've always gotten these questions wrong. So 7 is less than 9. That's how you read it. But if you wanted, you could also say that 9 is greater than 7, right? Like, for instance, if you have person A and you have person B, right? I'm sorry about my drawing, but you guys remember I'm not that great at drawing, right? So you have person A and you have person B. You could say that person A is shorter than person B, or you could say that person B is taller than person A. But in math, when you want to represent that, you would need to write it like this over here so that you can communicate the same thing. Otherwise, people will always read this as A is shorter than B. They're not going to read it as B is taller than A, right? So these are both equivalent. They're both saying the same exact thing, right? Think about it. This is very true. Both of them are true. But it's really the way that you write it, okay? Now, anyway, let's suppose that we were to multiply 7 by negative 2 and 9 also by negative 2, all right? Well, here's what happens. 7 times negative 2 is actually negative 14, all right? And 9 times negative 2 is negative 18. Now let me ask you this. Which one's greater, right? So it turns out that the negative 14 is greater. And that is why the rule exists. It says whenever you multiply or divide by a negative, the inequality is going to switch like that, all right? So I find that many students never knew why that rule actually works. And so I just wanted to take a moment and show you that exact thing. Now, the main segment of this lesson, we're going to spend the majority of the time on, and the rest of the time on basically, is to be working with different kinds of inequalities. Inequalities are a favorite on the ACT, so they have a lot of questions that are based upon these, inshallah. So I'm going to begin simple, all right, and then we're going to kind of start to graduate this and make it a little bit harder. So let's start with number 58. All right, let's start with number 58. And number 58 says that you've got 2x plus 5, right? So this is just solving inequalities, and each single time you're going to express your answer in interval notation, in set notation, right? And you're going to graph the solution set, all right? So, Bismillah, let's get started. You've got 2x plus 5 is greater than 1, all right? So I'm going to subtract 5 on both sides, right? In other words, I'm going to move the 5 over, so it becomes negative. So it becomes 2x is greater than 1 minus 5, which is negative 4. And then I'll divide by 2 on both sides, and I'll end up with x is greater than negative 2, all right? Now, we're going to go ahead and write this in interval notation. In interval notation, that same exact fact can be written as negative 2 on the side right here, like this, and then a infinity on the right side, and that's got a parenthesis. So this is called the interval notation, right? Now, if you want to graph the solution set, I personally prefer graphing before doing any kinds of notations. I'm just a visual person, and I know that a lot of you are as well, but the graph of it would have looked like open circle and then shaded towards the right, or the other graphical notation, of course. I know there's just a lot of notations in this lesson. So negative 2 parenthesis like that, right? Let me shade that arrow that way. And then this way, and then shade the arrow, of course. All right. So what we're going to do is, because there's a lot of questions to do, and I don't want to take like too much time, right? So what I'm going to do is, as I'm continuing with this lesson, inshallah, I am going to refrain from continuously pausing. I'm going to refrain from graphing it every single time. All right, let's take number 60 here. Number 60 says 2x minus 2 is greater than or equal to 3 plus x. All right, so 2x minus 2 is greater than or equal to 3 plus x. And in this situation, I would recommend that you move the x to the left side, right? And then one of the reasons why we do that is because the 2x is greater, the x is smaller. You want to move the smaller one over, right? Because that way you'll end up with a positive result, because greater minus smaller always gives you a positive number. And then you want to move the negative 2 over to the right side, like that, right? So 2x minus x gives you an x, and 3 plus 2 is going to give you a 5, like that. Of course, there is several notations that you can represent this in, okay? And I just want to highlight that for you again. But I'm not going to bother to do that right now, because obviously that's a different objective that you need to do in this lesson anyway, okay? You're welcome to look at it in the homework solutions and stuff like that later. Okay, let's go to the next question. We'll try number 64. Number 64 says that you've got 8 minus 4 multiplied by 2 minus x, and it's less than or equal to negative 2x. All right, so let's go ahead and solve this. Step number 1, you basically need to realize that you got to open up this parenthesis. So very similar to how we work with equations, really, okay? And so you end up with 8 minus 8 plus 4x. Notice how that the negative 4 times the negative x gives you plus 4x is less than or equal to negative 2x. All right. Now, same exact idea, except notice how the 8's will actually cross off. So you end up with 4x is less than or equal to negative 2x. So that works out for you. And then you're going to bring the negative 2x over to the left side, so that'll become a plus 2x. So you actually end up with something interesting. You end up with 4x plus 2x is less than or equal to 0, right? So when the negative 2x leaves, there's a 0 left over, right? I mean, there's nothing left over, so you write a 0 there. So 6x is less than or equal to 0, and therefore, if you divide by 6 on both sides, you end up with the answer x is less than or equal to 0, like that. All right? Let's try number 66. Number 66 says that you've got 3x plus 4, and it is greater than 1/3 x minus 2. All right. So first and foremost, we're going to multiply the 1/3 in like this. Or if you want to make your life a little bit easier and multiply the whole inequality by 3, you could do that as well. It's really your call. I generally find that just multiplying the entire thing by 3 would have done a lot better. But let's just do it this way though. Okay, so 3x plus 4 is greater than 1/3 x minus 2/3, like this over here. And then what we're going to do is we're going to bring the 1/3 x to the left side, and we're going to bring the 4 over to the right side, right? They're both going to take subtraction signs. So 3x minus 1/3 x on the left side, and on the right side, we've got basically negative 4 minus 2/3, right? So now let's do least common denominators. The least common denominator in that first situation is a 3, as well as in the second situation is also a 3, right? So now you end up with a situation where you have 9x minus x over 3 is greater than negative 12 minus 2 over 3, like that, right? And so you'll end up with 8x over 3 on the left side, and on the right side you'll end up with negative 14 over 3, right? Now you want to go ahead and solve for x. So how do you solve for x? You basically multiply by 3 over 8 like that. And if you multiply by 3 over 8, basically what's going to happen is the 3's will cross off, the 8's will cross off, so you are left over with an x on the left side. And on the right side, the 3's will cross off here, and negative 14 over 8 is the same thing as negative 7 over 4, like that. Okay. Now, I just want to give you a little heads up. Many students have failed to know where is negative 7 over 4 on a number line. Please realize if you don't know where negative 7 over 4 is, put it in a calculator and you'll realize it's negative 1.75. Okay, so that's a number between negative 1 and, excuse me, negative 1 and negative 2, right? So there's that. Now, I just want to give you an easier way to work with a problem like this. Okay, this is an easier, slightly easier way. It's going to save you a lot of time, and I'm going to try to use this technique more. Basically, notice how when I had said to you in the beginning, there's that 3 on the denominator, right? That's not fun. So what you're allowed to do is just multiply throughout by 3 first. So remember, we had 3x plus 4 is greater than 1/3 x minus 2. This is just a really handy trick. If you miss it, that's okay, all right? So if you were to multiply throughout by 3, what that would do is basically it would cross off this 3 and that 1/3. And remember that 1/3 is what caused a lot of that annoying problems and stuff like that. So you'll end up with 3 times 3x, which is 9x, and 3 times 4, which is 12, right? And on the right side, you basically have 1 times x and then 1 times negative 2. So x minus 2. See how much easier that is to solve, right? I would bring the x over and the 12 over. They both take subtraction signs. So I'll end up with 8x is greater than, bismillah, negative 12 minus 2 is negative 14. And look, you end up with the same exact conclusion as before, right? When you divide by 8 on both sides, this simplifies. But look how few steps I had to take, all right? I mean, 1 or 2 less steps. So just a quick note for you is whenever you have fractions in these questions, it may be a good idea to just kind of get rid of those fractions really quickly before you continue with that question. All right, so that was number 66 right there. Now we're going to do something called compound inequalities. So we're going to try number 70 here. Number 70 says that 4 is less than or equal to 2x plus 2 is less than or equal to 10. So in a compound inequality, notice how you got an inequality on the left side and on the right side, right? So you got inequalities on both sides, right? So you definitely have learned to solve these in algebra 1, sorry. And I'm just kind of going over these with you again. Basically what you do is you subtract by 2 on all 3 sides. And when I say 3 sides, there's the left side, the middle side, if you want to call it a side, the middle, and then the right side, right? So in the middle, the 2's will cross off, and on the left side, you'll end up with 4 minus 2, which is 2. In the middle, you'll have 2x, and in the right side, 10 minus 2 is actually equal to 8. So here's what that looks like. Now what you're going to do is you're going to divide by 2 on all sides. And when you divide by 2 on all sides, 2 divided by 2 is 1. 2x divided by 2, it's just basically going to cross each other off, so you end up with x. And then on the right side, you end up with a 4. All right? So where do you stop in a compound inequality? Basically, you wait till you get an x in the middle. You do all the operations that you need to, and then at that stage, you stop. I just want to take a moment and make sure that you know and understand what 1 of 4 looks like, right? A lot of people don't. They get confused. They try to read this as 1 is less than, right? I've seen this all the time, is less than 4. Of course, less than or equal to, that's not how you're supposed to read these, okay? What you really want to say is x is between 1 and 4 inclusive, all right? That's really how you read this. And so what does that look like? That means shaded circle, and then in the middle of the two, you're supposed to shade like that. That's really how you read number 70 right there, okay? Number 72, let's go ahead and give that one a shot. Negative 3 is less than or equal to 3 minus 2x is less than or equal to 9. So what's the first thing that we're going to do? We're going to try to get rid of that 3 by subtracting 3, like this. All right? And now the 3 is going to be gone. On the left-hand side, you're going to have 0. In the middle, you'll have a negative 2x. And on the right side, you'll have the number 6, like this over here. All right? Now, you're going to go ahead and divide by negative 2, but I want you to remember what happens when you divide by a negative number. The inequality is going to flip, all right? And then we have some things that we want to talk about here in a moment. So negative 2x divided by negative 2, obviously everybody knows that that's going to give you x, all right? 6 divided by negative 2 is going to become greater than or equal to negative 3. So I just want you to kind of think about this end over here and flipping that around. Think about how you would have said like that, and then you would have said 0, all right? So what are you really trying to say here, right? Because technically negative 3 is to the left of the number line, right? And 0 is on the right. So here's what I mean to say. All right, this is a tricky question. Initially it looks like it's just more of the same, but it's not. So you've got negative 3 and you've got 0. And I am telling you that x is a number that is greater than or equal to negative 3, but it's less than or equal to 0. So really, I'm telling you that it's between negative 3 and 0, inclusive. So this is really what that inequality is trying to communicate to you. But if you think about it, there is a better way to write that. You could have written negative 3 on the left side, then you put less than or equal signs, as we've been doing this whole time, and then you put a 0. So this is the more standard notation. All right? If you didn't see what I just did there, look, here it says greater than or equal to, greater than or equal to. All right? That's not a very good way to say things. You want to always write them in this notation. And so that basically what that does is it puts the lesser number on the left side and the greater number on the right side. Right? So it's a better way to go about it. And number 72 initially, it just looked kind of weird, but we fixed it, and this is how it's supposed to look like. All right, let's try number 74. I think we've run out of a little bit of space here, so let me just take this same exact canvas and copy it to a different spot. Okay, so number 74, it says that 0, number 74, 0 is less than 3x plus 2 over 2, which is less than 4. All right, so we got to do a handful of things here. But one of the first things that we got to do is we have to multiply by 2 on all sides. I'm going to multiply by 2 on all the sides. And when I do that, 2 times 0 is going to give me 0. All right. 2 times 3x plus 2 over 2 is going to cross off the 2, so you end up with 3x plus 2 like that. And finally, 4 times 2 is 8. All right, now what we'll do is we'll subtract 2 on all the sides, like this. All right, so it's kind of the same as the earlier one. So now you're going to end up with, bismillah, negative 2 on the left side. You're going to end up with 3x in the middle. And you're going to end up with 8 minus 2, which is 6 on the right side. And finally, the last step here is to divide by 3 on all the sides. And so you end up with, bismillah, negative 2/3 is less than x, is less than 2. And yet again, you've got your answer right there. Okay. I just want to remind you that negative 2/3, you guys, is negative 0.666 running, right? And so if you were to be putting this on a number line, and I really want to try this because this has, if I give this question to maybe 10 students, usually 9 of them will get it wrong, right? So I got to make sure that that doesn't happen with your class, especially because we're not face-to-face. So negative 2/3 is a number that is actually between negative 1 and 0. All right, and more like it's 2/3 of the way to negative 1. All right, and then positive 2 is all the way over here. So when we say something like that, you have to have one of the reasons why we use a number line is for students to understand where a number is. That's so important, right? So negative 2/3 and 2, and then we shade between them like this over here. Okay. All right, let's do one more, and then inshallah we'll wrap up with today's lesson. Number 76, it says 0 is less than 1 minus 1/3 x is less than 1. So the first thing that you'll realize is we got to subtract 1. All right, so I go ahead and I subtract 1 everywhere. So I end up with 0 minus 1 is negative 1, and this crosses off. I have negative 1/3 x in the middle, and on the right side I have a 0. Okay, so let's continue now. What do we need to do now? We're going to multiply by negative 3. All right, so we're going to multiply by negative 3 on all the sides. And when we multiply by negative 3 times 1 is going to give you 3. And because we just multiply by a negative, we're going to flip the sign. Just want to highlight that for you. We're going to flip the sign on the inequality, so it'll look like the following. And in the middle, the negative 3 and the negative 1/3 are going to all cross off, all right? And you end up with a x in the middle. And on the right side, 0 times negative 3 is 0. Now, what did I tell you earlier? It's a good thing to put the smaller number on the left side, the larger number on the right side, x in the middle, of course. But then what that does is it allows you to go ahead and flip these inequalities again, okay? I have personally seen this question on the ACT, and it's one of the hardest questions because people mess this up all the time. So try to wrap your mind around what we just did right there, okay? So thank you so much for listening, and good luck with doing the homework. Remember that you do need to express things in at least the interval notation and the graph of it when you're doing the homework problems. Thank you, and assalamu alaikum.